Hey, it's Calc&Compile, your shortcut to simple math and computing.
In this question, R is 1, 2, 2, 3, and 3, 4, and S is 2, 3, 3, 1, and 4, 2. And we have to find SOR, which means S composition R composition S, R inverse composition S, R composition S inverse, and R inverse composition S inverse. So the shortcut for composition of relations, S composition R or SOR means for, do R first and then S. So A comma C belongs to composition relation SOR if and only if there exists B with A comma B belonging to R and B comma C belonging to S. Now first S composition R or SOR, we have to check for each A comma B belonging to R and see if there is B comma C in S. From 1 comma 2 in R, S has 2 comma 3 which gives us 1 comma 3. For 2 comma 3 in R, S has 3 comma 1 which gives us 2 comma 1. From 3 comma 4 in R, S has 4 comma 2 which gives us 3 comma 2. So SOR or S composition R is 1 comma 3, 2 comma 1 and 3 comma 2. Now R composition S or ROS, do S first then R. From 2 comma 3 in S, R has 3 comma 4, so it gives us 2 comma 4. 3 comma 1 in S, R has 1 comma 2, so it gives us 3 comma 2. From 4 comma 2 in S, R has 2 comma 3, so which gives 4 comma 3. So ROS or R composition S is 2 comma 4, 3 comma 2 and 4 comma 3. For R inverse and S inverse, you have to invert each ordered pair. Now R inverse composition S or R inverse OS, do S first then R inverse. For 2 comma 3 in S, R inverse has 3 comma 2 which gives us 2 comma 2. For 3 comma 1 in S, R inverse has no pair starting with 1. So for 4 comma 2 in S, R inverse has 2 comma 1 which gives us 4 comma 1. So R inverse OS is equal to, or R inverse composition S is 2 comma 2 and 4 comma 1. Next, R composition S inverse or ROS inverse, which means do S inverse first then R. For 3 comma 2 in S inverse, R has 2 comma 3 which gives us 3 comma 3. For 1 comma 3 in S inverse, R has 3 comma 4 which gives us 1 comma 4. For 2 comma 4 in S inverse, R has no pair starting with 4. So ROS inverse or R composition S inverse is equal to 3 comma 3 and 1 comma 4. Now R inverse composition S inverse or R inverse OS inverse, which means do S inverse first then R inverse. For 3 comma 2 belonging to S inverse, R inverse has 2 comma 1 which means 3 comma 1. For 1 comma 3 in S inverse, R inverse has 3 comma 2 which gives 1 comma 2. For 2 comma 3 in S inverse, R inverse has 4 comma 3 which gives us 2 comma 3. Therefore R inverse O S inverse is 3 comma 1, 1 comma 2 and 2 comma 3. R equal to 1 comma 2, 2 comma 3 and 3 comma 1 on A equal to 1, 2, 3. Find R inverse, R union R inverse and check whether my R intersection R inverse is symmetric or not. So R inverse means inverse relation, meaning flipping each ordered pair. So R inverse is this. R union R inverse, take all pairs from both sets but no repetition. So R union R inverse is this. R intersection R inverse, take only pairs common to both. Here in R and R inverse no pair is common, so R intersection R inverse is phi or null set. Since there are no elements at all in the intersection, the condition for symmetric, so symmetry is automatically satisfied. Therefore, R intersection R inverse is symmetric. This question, f is equal to 3x plus 2, which is from R to R set of real numbers. We have to prove f is bijective. So a function is bijective if it is both 1 1, which means different inputs give different outputs, and onto, which means every element of the codomain has a pre-image in the domain. So first we have to prove f is 1 1 or injective. So suppose f of x1 is equal to f of x2. So 3x1 plus 2 equal to 3x2 plus 2. By subtracting 2 on both sides, we get 3x1 equal to 3x2, and dividing by 3, we get x1 equal to x2. Therefore, f is 1 1. Now, to prove f is onto or subjective, let y belong to real number. We need to find x belonging to real number such that f of x equal to y. So y equal to 3x plus 2, 3x equal to y minus 2, so x equal to y minus 2 by 3. Since y minus 2 by 3 is a real number for every real y, there exists such an x. So every y belonging to real number has a pre-image, therefore f is onto, and as f is 1 1 and onto, it is bijective. F of x is x square and g of x is equal to x plus 1. We have to find f plus g of x, f minus g of x, f dot g of x, and f divided by g of x. So by definition, f plus g of x can be written as f of x plus g of x, which is equal to x square plus x plus 1. Similarly, f minus g of x can be written as f of x minus g of x, which equals to x square minus x plus 1 whole, so which equals to x square minus x minus 1. F dot g of x can be written as f of x multiplied by g of x, so it is x cube plus x square. F by g of x can be written as f of x by g of x only when g of x not equal to 0. So f by g of x equal to x square divided by x minus 1, x plus 1, where x is not equal to 1. In this question, f of x is equal to 2x plus 3 and g of x equal to x square. We have to find f composition g of x or f of g of x and g composition f of x or g of f. So f composition g of x or f of g of x can be written as f of g of x. First apply g, then f. So f of which is equal to f of x square. So f of g of x is 2x square plus 3. Now g composition f of x can be written as g of f of x, which means first apply f then g, which is equal to g of 2x plus 3, which is 2x plus 3 whole square, 4x square plus 12x plus 9. This question we have to find the inverse of f of x, which is equal to 2x minus 1 by 3, and define the characteristic function of a1 comma 3 comma 5 on u1 comma 2 comma 3 comma 4 comma 5. So first let f y equal to f of x. So y equal to 2x minus 1 by 3. So 3y equal to 2x minus 1. So x equal to 3y plus 1. So we can write f of x inverse or f inverse of x equal to 3x plus 1 by 2. Now about characteristics function, it is denoted by chi, Greek character chi. So chi of a from u to 0 comma 1. Characteristic function range is only 0 comma 1. So it is designed as g of a of x is 1 if x belonging to a and 0 if x doesn't belong to a. So here as a equal to 1 comma 3 comma 5, so g of 1 is 1, g of 2 is 0, g of 3 is 1, g of 4 is 0, and g of 5 is 1. So g of a from u to 0 comma 1 is 1 when x equal to 1 or 3 or 5, and 0 when x equal to 2 comma 4. In this question we have to test convergence of sequence an equal to 2n divided by n plus 3. A sequence an converges to a limit L if L equal to limit n tends to infinity an. So limit n tends to infinity 2n divided by n plus 3. So dividing n on both numerator and denominator, we get limit n tends to infinity 2 divided by 1 plus 3 by n. As x tends to infinity, n tends to infinity, 3 divided by n tends to 0. So limit L equal to 2 divided by 1 plus 0 equal to 2. Therefore the sequence an equal to 2n by n plus 3 converges to 2.
Thanks for watching. Don't forget to like, share, and subscribe. See you in the next one.